All right, in this video, what we're going to do is generalize what we found from at the ends of the polynomials based on the degree and the lead coefficient, along with a few other things. We're going to generalize some information about the number of possible zeros for a polynomial of degree n, and also the number of relative minimums and maximums. So this first question asks you, what do you notice about the end behavior of the functions that had an even degree? So if the degree of the polynomial was even, what did you notice about the ends of the graph? And I want you to think about it, go back, look at all the graphs that we did, which were, we only did two even degree polynomials. We graphed a quadratic and a quartic, so degree 2 and degree 4. And if you look at the ends of those graphs, degree 2 is a parabola, which we know from previous units, and both ends of the graph went up, or both ends of the graph went down. But they always go in the same direction. If you look at the quartic, fourth degree, the ends both go up, or the ends both go down. And if you graphed a 6th-degree polynomial, you find the same thing, that the ends are going to go in the same directions. And so that is basically the generalization. If it's an even degree polynomial, meaning the term with the highest power is even, the term with if the highest power is an even number, then the ends of the graph go in the same direction, either both up to positive infinity or both down to negative infinity. And so then I want you to take a look at what happened with the odd degree. We did a linear function. The ends go, one end went to positive infinity while the other end went to negative. Or it could go negative on one side and positive on the other side. Then we had a cubic. Again, the ends, one goes up, one goes down to positive infinity and negative infinity. Same thing here. And we looked at quintics, which is a 5th degree. One end goes up, one end goes down to negative infinity, and same thing with this graph. And in general, the ends of a graph of a polynomial of odd degree head in opposite directions. One way to kind of remember this is if it's odd, kind of looks like the same as op, sort of. So odd degree polynomials go in opposite directions. So you're either going to go one up, one down, or it might be the reverse of that. And if it's an even degree, both ends go up, or both ends head down to negative infinity. Okay, now reflect on this one. How does the lead coefficient affect the graph for functions that are of even degree? So go back and look at the graphs, the 2nd degree polynomial, the quadratic, and the 4th degree. And in one situation, both ends go up, and the other situations, both ends go down. Look at the lead coefficient. It's going to tell you which way those ends are going to end, up or down, for the even degree. So look at your polynomial, look at the lead coefficient, and it has to do with whether they are positive or negative. And I want you to analyze it, look at it, and determine which way the ends go based on the sign of the lead coefficient. And do the same thing for functions that are of odd degree. and write your answers here. And if you are struggling with that, let me know. We'll go over it in class, but I want you to try to do that on your own. Okay, the next question asks you, how can you determine the number of possible zeros if you know the degree of a polynomial? And so we've gone through this when it was a first degree polynomial. We had 1 real zeros for both of those graphs, and they're lines, and so that's the only option that we're going to have is 1 real zero, because one end's going up and one end's going down. Unless you have a horizontal line, then it might have 0 zeros, but that's the only situation for a linear function. So when it's degree 1, we had 1 0. When it was degree 2, well, this first graph has 0 zeros, but this one had 2 zeros. And think, could you ever have more than 2 zeros if your graph is a parabola? The answer is no. So you could have 0 zeros. You could have a situation where you have just 1 0. I'm supposed to be touching here. Or you have up to 2 zeros. So again, we're generalizing this, so keep that in your mind. For the cubic function of degree 3, we have, for this situation, we have 3 zeros and up to 2 twists and turns. Also keep that in mind. And over here we had, well, I shifted this up in the video, but the actual graph, the original graph that we have looks something more like this. And so we had 3 zeros, but you could have 2 and you could have 1. You can't have 0 zeros with a cubic because the ends go off in opposite directions, so they're going to have to cross through the x-axis at some point. And I'm talking about real zeros here, not the imaginary or complex zeros with the imaginary unit. Fourth degree, you could have 2 real zeros, and in both of these situations we had 2 real zeros, but we went through them and looked at, like, if I shifted this up, I could have, right now I have 3 real zeros, 3 x-intercepts. Here I have 4. Supposed to be right up there. So you could have up to 4, but you'll never have more than that. And then the quintic, we had 5 for both situations, 5 real zeros. But again, if I shift the graph, oops, this graph's falling apart. Let me redraw that. Shifting the graph up and down doesn't change the degree or the lead coefficient. What it's going to require to shift a graph up or down is to add a constant. So if I shift this up, you could have 1, 2, 3 zeros in that situation. I'm going to actually delete that graph. And let's look at this situation. For this 5th degree polynomial, right now I have, we have 1, 2, 3, 4, 5 real zeros, or 5 x-intercepts. If I shift up a little bit, you could have 1, 2, 3, 4. And if I go up higher, I have 1, 2, 3 zeros. I can go even higher. And I would have 2, this one right here. And then this, remember, this is going to go down forever, so it would eventually cross the x-axis. Or I could have it shift up even farther, and then we just have this 1, 0 as it goes down to negative infinity on that side. So you can have anywhere from 1 to 5 zeros for a 5th degree polynomial. So generalize that. How do you know the possible number of zeros, of real zeros, if you know the degree of the polynomial? Again, if you're having trouble with that, bring your questions to our next Zoom meeting and we'll go over it. And then how many twists and turns can a polynomial of degree n have? Remember, our linear function had 0 twists and turns, or relative minimums and maximums. So the degree 1 had 0. Degree 2 had 1 twist and turn. degree 3 can have up to 2 twists and turns. Degree 4 has up to 3 twists and turns, or relative maxima, minimum values, and then the degree 5 has, let's see, 1, 2, 3, 4, up to 4 twists and turns. So what do you think you can say about how many twists and turns a polynomial of degree n can have? And then the last question, a polynomial has the following n behavior. So this is telling you that f of x, the y coordinates are going to infinity when x goes to infinity, and to negative infinity as x goes to negative infinity. So they're going in opposite directions. So think about what that means. And then if they're going in those directions, what do you know about the lead coefficient of the polynomial? That is like the general, this is what we really want to get down to, the nitty-gritty. How do you know the degree of a polynomial? By looking at the graph. And what do you know about the lead coefficient of the polynomial? By looking at the graph. So you guys fill this, the rest of this out, bring your questions to class, and we will go over your questions then. All right.